this video I am going to explain Module 4 Chapter 2 Multiple Access. I am going to give the introduction of multiple access. What is multiple access? When node use shared medium. That medium is nothing but link between those nodes. Okay, we need multiple access protocol. Means when nodes are using the shared medium, means then to control that have to use multiple access protocol. Okay, here many protocols have been designed to handle access to shared link. There are some protocols are designed for handling this access to shared link or shared medium. You can see that in this diagram multiple access protocol. Under that there are three types of protocol: random access protocol, controlled access protocol, channelization protocol. Under random access protocol there are four types. One is ALOHA CSMA, means carrier sense multiple access. Next one CSMA CD, means nothing but carrier sense multiple access. Bar CD means collision detection. Next one is CSMA CA, means carrier sense multiple access collision avoidance. Okay, next under control access protocol there are three types: reservation, polling and token passing. Next one channelized protocols. There are three types: FDMA, TDMA, CDMA. Okay, here you can see that this protocol are belongs to sublayer in the data link layer called media access control. Means there is a sublayer called media access control in the data link layer. This all protocol present in this sublayer of DDLA, nothing but MAC, means media access control. Means this all protocol present in the DDL sublayer media access control. Now we discuss this random access protocol and four types of random access protocol. Here random access protocol. No station is superior to other station, means no station is giving importance to other station. No station is assigned control over other station, means no station will be taking control on other station. One station need to send data, then station make decision on whether or not send data. Means one station need to send the data, means that station will take the decision whether to send or not send the data. Station decision depend on the state of the media. Means the decision of the station which is going to send the data is depend on the state of the media. There are two status: if media is idle or media is busy. Okay, this is called random. So suppose if the state of the medium is idle, then the station will send the data. If the medium is busy, the station will not going to send the data. This is called random access. Because why we are going to call it this is random access? Transmission is random among the station. No scheduled time for the station to transmission. Why we are going to call it as random access means no schedule for the station to transmission means there is no there is no scheduled time for any station for the transmission. Okay, this random access also called as contention method. Why we are going to call it as this random access as a contention method? Because station compete with one another to access the media. Means if there are four station is there, the fourth station wants to access that media, then this four station will compete to access that single media. So it is called as contention method. Each station follow a procedure that give answer for the following question. Means there are some four questions are there. The station follows some procedure that will give the answer for this four question. What are that four question? When can the station access the media? Means when the station can access that shared media. Next, what can the station do if the media is busy? Suppose if the media is busy, what station will do? That is second question. How can the station determine the uh, success or failure of the transmission? Means how station will come to know whether the transmission is success or not. Next, what can this station do if there is a collision? Means what station will do if the transmission has the collision between the packets? Means there will be a mixing of the packets is called as collision here. Means if suppose A will send the packet, B will also send the packet, and there is a collision. Means there will be a confusion and there is a slowdown of transmission, that is collision. What can the situation do if there is a collision? There are four questions are there. The station will follow some procedure that will give the answer for this following question. We will discuss the answer for this four question in coming topics. Okay, I told that there will be a four types of random access protocol. We will discuss first one, Aloha protocol. In Aloha protocol there are two types. One is pure Aloha, second one is slotted Aloha. What is meant by Aloha we will discuss first, then we will discuss pure Aloha, next we will discuss slotted Aloha. Here what is an Aloha? It is designed for wireless LAN. Means wireless local area network, but can be used on any shared media. But it is specifically designed for wireless LAN, but it can be used for any shared media. Here the medium shared between the station, you can see that this is the media, this is shared media, this is used by n number of station. Here the sharing of this shared media will result in the possibility of collision. Means if you are sending the all the station data at a time means there will be a possibility of collision and data loss. Means suppose station 1, 2, 3 will send this data at a time to shared media, means it is possibility of collision and data loss. Okay, this is Aloha. Under Aloha there are two types: pure Aloha, another one is slotted Aloha. We'll discuss what is meant by pure Aloha. In pure Aloha, what will happen means, suppose there are three stations. This the station will send the data to the receiver. The receiver also will send the acknowledgement. Okay, I told that sender will send the data. While sending the data, the sender will set the timer. Okay, after sending the data from source to destination, after data is received by the destination will send the acknowledgement to sender. Okay, but this acknowledgement will not received by the sender within the given time period. Okay, then it will the sender will resend the same data, assuming that the data or acknowledgement are destroyed. But here what is happening means, in this case, suppose this three station will send the data at a time, means it may be possibility of collision. Okay, collision means you can see that this is collision duration, this is also collision duration, means there will be a collision between the station 1 data, station 2 data, station 3 data. So here also you can say that station 2 data, station 3 data are collision here. Okay, it will be collision if we send the data at a time from each of the station. To overcome this collision, there are two types. We are using randomness and limit maximum retransmission. Using these two methods, we can control the collision in the pure Aloha. Randomness. What is meant by randomness technique here? When the timeout period passes, then each sending station wait random amount of time before resend the frame. Okay, this time is called as back of time, means they are telling that once we will send the data from source to destination, if the acknowledgement is not got within the time period, means the sender will wait for random amount of time for resending the same frame. That time is called as back of time. This helps in the avoidance of collision. This method ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ it will help for the avoiding of the collision, means we will send the data, will set the timer. After receiving by the receiver also send the acknowledgement, but acknowledgement will not got from received by the sender within the time period. In that time, the sender will wait for random amount of time to resend the same frames. Okay, this waiting time is called as back of time. What is the advantage of this waiting randomness of time means it will help to avoid the collision. Next method is limit maximum retransmission. After maximum retransmission attempt, Okay, attempt. Station must give up and try again later, means after maximum retransmission, means they are telling that you will do n number of time retransmission. Okay, you will do n number of retransmission, but also it is not going for success of receiving by the receiver, and that time you give up that time and try again later. They are telling, means suppose you are calling for one person in the phone, means they are not picking the phone, so leave for 5 to 10 minutes and try again. That is the meaning of this limit maximum transmission. Okay, this is pure aloha. In pure aloha there is two topics: valuable time. Valuable time is time during which collision happen, nothing but the time in which the collision can happen. That time is called as valuable time. Pure valuable time is equal to 2 into TFR. This TFR is nothing but frame transmission time. Okay, you can see in this diagram I told that time during which collision happens. You can see that there are two times where collision is happen. You can see that the collision happen S end and B's beginning. You can see that this is the frame of A station, this is the frame of B station, this is the end of A, this is the beginning of B. Here the collision is happen. One collision is happen. Second collision, here you can see that ends, B's ends and C's beginning. There is another collision. So 2 into TFR means two collision with frame transmission time. This is the formula for pure allowance variable time is equal to 2 into TFR, frame transmission time. Okay, next, through output. Average number of successful transmission is called as through output. Average number of successful transmission means suppose you are sending 1000 frames, how many frames are successful out of this 1000 is called as through output, means average number of successful transmission. You are transmitting 1000 frames, means out of 1000 how many frames are successfully transmitted. That is the through output. That is given by S is equal to G into E of minus 2G. Here G represents the average number of frames in one frame transmission time. Okay, average number of this G represents average number of frames in one frame transmission time. Okay, this frame transmission time is number of transmission frame by capacity of the cable. Okay, here there is one problem that suppose the transmission number of transmission frame is 200 bit per 200 and capacity of link. Okay, what will be the frame transmission time, and it will produce 100. Okay, they give the number of transmission frame and capacity of the medium. Here 200 bits divided by capacity is 200 kbps. Then we will get 1 millisecond. Now this we have to calculate the using this transmission frame transmission time. You have to calculate the flow output of the sum of the frame transmission per second. First you have to calculate the flow output for 100 frames per second, next 500 frames per second, 250 frames per second. Here I told that G represents the average number of frames in one frame transmission time. Here it will convert it into milliseconds. This will convert it to millisecond means 1 frame per millisecond, half frame per millisecond, 1.5 frame per millisecond. Then this is the average number of frames in one transmission. Then it will be value for G is equal to 1. Then I will apply, only you concentrate on this blue color explanation. S is equal to G value 1, E value as it is 2 into G value 1, we will get 0.135 means 30.5 percentage of out of this 1000 we can only successful is 13% of this 1000. Next, when we try to send 500 frames, how many percentage of frames going to successful means 18.4 percentage of frames of 500 will be successful. After 250 only 15.4 frames will be successful. This is the output of pure aloha. Okay. Next we will discuss slotted aloha. Okay, what is meant by slotted aloha? Slotted aloha increases the efficiency of the pure aloha, means it will increasing the percentage of successful transmission of the frame. Means pure aloha there will be a less efficiency. To improve the efficiency of the aloha, pure aloha, we are using the slotted aloha. Here time is divided into time slot of frame transmission second. Means here you can see that there is frame transmission time is 1 millisecond. Means for each 1 millisecond there will be a one slot. Here first millisecond, second, third, fourth, fifth, sixth, like this. For each 1 millisecond there will be a one slot. You can see that time divided into, this is time, it will be divided into time slot based on frames transmission second. Station are allowed to send frame only at the beginning of the time slot. Means they are giving the permission to send the data when slot are begin to form. Means they are giving permission, stations are allowed to send the frames only at the beginning of the time slot. Means when you are doing this time slot, that time slot we should send the frames, otherwise we cannot send. Okay, this is. Then if station misses the time slot, means suppose the one station is missed to send the data in the beginning of time slot, means station must wait until the beginning of second time slot. First slot beginning ಅಲ್ಲಿ some station will miss to send the data, means it should wait for sending their frames or data for the second slot. If two stations try to resend at the beginning of same time slot, frames will be collide again, means they are telling that if two stations are resending their frames at the same time slot, means again there will be a collision. You can see that in slot to slot 3 there is a collision because B station also sending, C station also sending the frames. Here A station also, D station also, here collision, here collision. Okay, here also there is a collision, but compared to pure aloha, here collision is less. Okay, here what is the valuable time? Nothing but valuable time is equal. Valuable time is nothing but what is valuable time? Time during which collision happens. Here you can see that there is a one collision. So the formula is only TF only formula is TFR. Valuable time is equal to frame transmission time here. Okay, here what is valuable time is time in which collision happen. Here collision happen, B will be collide with C, means when B frame C frame are in same slot there will be a collision, means variable time is equal to frame transmission time. When this time will happen means when frame is transmission time. Okay, what is the true output of slotted aloha? Here you can see the difference. Here you can see the difference. Here S is equal to G into e to the power of e to the power of minus 2 GL minus 2 ಇದೆ ಇಲ್ಲಿ minus 2 ಇಲ್ಲ. Okay, only G is there. That is the difference between pure aloha and slotted aloha. Okay, means they are tell that we are going to improve the efficiency of the pure aloha. Okay, same frame transmission is same and number of frames for sending for each second also same. You can see that increasing in the percentage of transmission of the frames here. Okay, this is for pure aloha 13%. Here it is increased in slotted aloha 36. Here 13, here 36. Next 18, here 30%. Okay, here pure aloha 15%, here 19%, means there is a increasing in transmission of frames in the slotted aloha, means it is increased efficiency of pure aloha. Okay, this is the completion of aloha. We are move on to next type in random access protocol is CSMA. What is CSMA? Carrier sense multiple access. Carrier sense multiple access. Minimize the chance of collision. Improve the means increase the performance. Means we are using this carrier sense multiple axis. We are going to minimize the collision. Means you are going to reduce the collision happening and improve the performance. Automatically there is a less collision, means performance will be high only. Okay, it is work on the principle sense before transmission, means before transmitting you have to taste, that is the sense before transmits, or listen before talk. Means ಏನಾರ ನೀವು ರಿಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟು ಲಿಸನ್ ಮಾಡಬೇಕು. ದಟ್ ಈಸ್ ದಿ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ದಿಸ್ CSMA. How it will be working means station check status of the medium, but here what station will do means it will check the this is station means this is medium means this station will check the medium it is idle or busy. Means idle means not busy. Okay, if media is idle, station send the data. Means ಈ media busy ಆಗಿಲ್ಲ ಅಂದರೆ it will send the station will send the data. If line is busy means station defer sending, means it will not going to send the data. Okay, CSM can reduce the possibility of collision but not eliminate it. Means it can it is not giving 100% I will vanish the collision. It is telling that it will try to reduce the possibility of collision but not confident here. That is the meaning of reduce the possibility of collision but not the eliminate it. It complete ಆಗಿ collision ನ eliminate ಮಾಡಲ್ಲ, but it can reduce the collision. Means ಒಂದು 10% ಒಂದು 100% ಇದ್ರೆ collision ಬೇರೆ ಇದರಲ್ಲಿ ಇದೊಂದು 60% collision ನ ಕಮ್ಮಿ ಮಾಡುತ್ತೆ. That is the meaning of this reduce possibility of collision. Okay, here valuable time. What is the valuable time of the CSMA? What is valuable time is nothing but time in which collision happen. ಈಗ here variable time is equal to propagation time. What is propagation time? The time in which the frames will transfer from one station to another station. It is called as propagation time. What is propagation time? Time is taken to travel a frame from one station to another station. That is called as propagation time. Means you can see that valuable time is nothing but time in which collision happen. Here also there is a collision. You can see that here also there is a collision. Here to here there is a collision. So valuable time is equal to propagation time. The time in which the data is sending from one station to other station, it is propagation time. The propagation time is equal to collision time here. That's all. Persistent methods. What is this persistent method? This is a question. What should a station do if channel is busy or idle? I told that the station will sense the media it is busy or idle. If it is busy it will not going to send the frames station. Okay, if media is idle it is going to send the frames. That is the answer for this question. But there is three methods of persistence methods. First one is one persistent, non-persistence, another one is persistence. Okay, in first persistence, here the station will check the condition the channel is busy or not. Channel is busy, it will going to back and again it will sense. If it is not busy it will going to transmit the frame. It will If it is not busy means it is busy means it will going to sense again and again. Okay, here here the collision is more in one persistence because there two or more than two station can sensing the same media. If all the station are sensing the media is idle means there are possibility of sending the frames at a time, then collision will happen. Okay, this is on persistence. Here the collision is more in persistent method A. Here it is the condition. Station will check the condition channel is busy or not. It is not busy means it will send the frame. It is busy means it is again it will sense again and again. Okay, you can see that loop is continuing here. Okay, next one is non-persistence. Here what will happen means here also station will send, here also the station will sense the channel is busy or not. If it is not busy it will going to send the this frame. If it is busy, channel is busy, ಅವಾಗ ಏನು ಮಾಡುತ್ತೆ, the station will not send the frames here, then it will wait for the random amount of time for sensing again the channel. Means station again it will going for wait for 10-20 minutes, then it will sense the channel. Okay, that is the non-persistence. Third one is P persistence. In P propagation method, it is use the channel as a time slot with slot duration is greater than or equal to propagation time. Means this method use the channel as a time slot with propagation time less than or equal to sorry here the channel has a wait slot with slot duration is less than or equal to propagation time. This is the condition. Here what will happen, here what will happen means we are going to use channel as a slot with slot duration less than or is equal to propagation time. Okay, propagation time. Here how it flow chart work means the as usual station check the line it is busy or not. It is not busy, it is busy means we are going to sense again and again. If it is channel is not busy means it is going to send the it will transmit the frames here. Suppose the channel busy phase means channel busy ಆಗಿಲ್ಲ ಅಂದರೆ on priority of P means this condition is true means it will send the packets or frames means station can transmit means it can send the their frames. Suppose this condition is fail means it will wait for starting the second slot. Okay, it will wait for the beginning of the next slot. Okay, then it will check the line again means channel are busy or not. If it is fails means channel is busy means it will go to backup process, otherwise it will send the transmission. Okay, means it will go to first step, otherwise it will go to backup process. I will tell once again. First station will check channel are busy or not. If it is not busy, it will going to check the second condition. This R is less than or equal to P. If this condition is true, then station can transmit. Otherwise, it will have to wait for the beginning of the next slot. Okay, then it will check the channel once again. If it is busy, next it will go to backup process. If it is not busy, means it will go back to first step, means you can then you can check this and we can send the transmission. Okay, this is the end of the two methods of random access protocol. First one is Aloha, second one is CSMA, carrier sense multiple access. Tomorrow, sorry, in next video I am going to explain this too. Okay, bye, thank you.